Good morning, Odile and Julie.
Hi, can you hear me?
I can hear you. How are you?
Awesome. Good, thank you. I guess, could you put me as a co-host?
Odile, I do not have host responsibilities.
Okay, so do I then claim the host, or does maybe Maribeth one?
All right, let me just send you an email to see if I can make you the host. Give me about 5 seconds.
I can claim the host, huh?
Okay.
I think I can do this, and I need the host key to claim. I will check in my, if I did receive it or not, I'm not sure. Don't remember.
So Federica, she should have sent it to you yesterday, or maybe a couple of days ago. Odile, I just sent you an email.
Yes, okay, I got it. I think I found the password, or wait, doesn't work.
Can you hear me?
Yes, we can hear you.
Thank you.
Good morning. Good afternoon.
Good morning from Alaska.
Good morning from Calgary.
I'm Kathy.
Hi, I'm Maribeth. We're gonna sit tight for a few minutes and see how many people we get, and then we'll start.
That sounds great. I'm gonna sit here on mute till it's my time to talk.
Hey, Maribeth. Can you hear me?
I can.
Do you want that I make you a host or a co-host? Not sure?
I think co-host is fine.
Co-host is fine?
Yeah.
Okay. Is there anyone else that need to be co-host or?
So Odile, if you don't mind making me a co-host as well, and
Sure.
if you see Anne Garland on, she should also be made a co-host. She's on her way. She's on her way.
Okay, she's not in the list. Yes, in the list here. For the breakout room, do you know already how many breakout room you would like? And
We're thinking 3, but depending on how many people, we might only need 2.
okay. And I guess you don't know yet who it's gonna be in which breakout room.
I will run one. Ravi will run a second one. And if we need a third, Anne Garland will run that one.
Okay. Well, hopefully it's gonna go smoothly.
Mm-hmm. Okay, I think we'll get started if that works for everybody. Can everyone hear me okay? Great.
Yes.
Great. So Ravi, I'm going to have you run through the agenda and then we'll do the presentations and then we'll have some discussion about how we're going to manage the smaller breakout groups. Does that sound okay?
It does, definitely.
All right. So first of all, welcome everybody. Thanks for joining us today. So far, so good. Things seem to be going well with the Observing Summit, even though we're all scattered all over the earth and disconnected, a little bit disconnected. I'm just going to give you all a heads up. I'm out in the country and I sometimes have unstable internet. So if I disappear, Ravi will take the reins. And I'm going to turn it over to him now to run through the agenda.
Okay, good morning, good afternoon, evening, and welcome to everyone. The Circumpolar Arctic is the contemporary home to many different indigenous peoples. As researchers and others who are working in or reside in the Arctic, we recognize these lands and waters as the mostly unceded traditional homeland of the indigenous peoples. It is the responsibility of each of us to learn, know, and gain better understanding of the indigenous people and cultures with which we engage. So with that in mind, let's engage in open-minded community building collaboration as described by the ASSW Code of Conduct that I'm happy to point you to the AOS2020 agenda.org website, and you should be able to read the entire Code of Conduct. Again, please do so at your leisure. All right, so again, good morning. I hope that everyone is doing well, healthy and secure. Thank you, of course, for your assistance in helping us transition to this online format. We really could not have done this without you. Now, as you can see on this slide, we do have a welcome from Maribeth, and I'm going to go through pretty much an overview of our working group's charge. And maybe after that overview, we will come back, do a roundtable, introduce everyone, and have a conversation around the AOS and roads process. And then we will go into several presentations. We're happy to have at least 12 or 13 people that submitted white papers, short statements to Working Group 2. So we will come back and do those presentations. All right, so for those who are not aware, Working Group 2 will focus on the holistic environmental issues and the role of observing and developing economically viable options in support of adaptation and mitigation. Based on the white papers and short statements that were received, like I just mentioned, we received 12, and those were received in advance of the summit. We identified 3 key threads that were addressed, and these were related to the successful use of observing technologies to facilitate things like decision support, adaptation initiatives, and mitigation strategies. Now, if you've yet to peruse our synthesis paper, please do so when you have some time. We've sent it around to many of you on this call today, and it will be posted at some point today on the AOS2020 agenda.org website. But several submissions to Working Group 2 in advance of the summit also identified areas where observing really needs to be ramped up in support of adaptation and mitigation. Now, SAON, as you know, has really emerged as the governance body that facilitates collaboration towards sustained observations. And they have identified the development of what's referred to as a roadmap for Arctic observing and data systems. So throughout the next 2 or 3 days, you'll hear us refer quite a bit to the acronym ROADS. And this is really just a key starting point for implementing SAON's strategy. ROADS is really designed to be a collaborative vehicle to unify the many voices of the broad community of practitioners into what's really a more coherent and actionable collaborative strategy for Arctic observing. And I encourage you, in case you haven't already listened to Sandy Starkweather's keynote, to do so, as it provides an excellent overview of the process and highlights many of the ROADS principles and assumptions. You're seeing some of them highlighted on this slide. But additionally, Sandy will be our guest for session 2 later today, and she will give a presentation, a short 15 to 20-minute presentation. So I invite you to be a part of that as well. But just to go back to this slide, it really gives a good overview of the SAON ROADS process. I know that several of you have already, you're already aware of many of the interacting components that you see present on this slide, having read the framework documents that were circulated in advance of the summit. But I'd really like to emphasize that the key goal of AOS 2020 as a whole is to help us find ways under the SAON ROADS umbrella to allow different observing initiatives that you're seeing on the left, for example, different observing systems, various observing activities from the small scale. So what we refer to as single investigator driven to large scale national and international programs to really better connect and coordinate amongst themselves around the focal lens of well-defined requirements for central variables and clearly identified shared societal benefits that we will expand on today. So this area here you see in the middle of the slide in yellow is the core foundation for those discussions, or for the discussions we are having and we plan to have over the next 2 or 3 days, using the concept of the Arctic Observing Roadmap to arrive at a point where we can get to co-design or jointly implemented and integrated observing system components. And these components are driven by and through individual sets of activities under, again, the umbrella of the SAON ROADS map. Now, the role of the AOS in this ROADS process really builds on several activities, but output from Working Group 2, Observing in Support of Adaptation and Mitigation, will really focus on one specific activity. And that activity is defining what is an essential Arctic variable, as these, what we refer to as these EAVs, need to really be clearly outlined. Now, Sandy again alludes to this in her keynote and one of her framework documents, but EAVs link to a single thematic bundle of potential observations. So things such as sea ice, and these EAVs are tied to important shared societal benefits. And some of those societal benefits you see on this slide. Maribeth, I'm not sure if you want to jump in here and just have the conversation around the societal benefit areas.
Sure. So as most of you probably know, these are sort of building off the SBEs developed by the UN, but they're Arctic specific. And if you haven't read the document, on the SAON website, there is a document that outlines these in much more detail. I'm thinking for our group, when we do into our smaller breakout groups, that we could pick 1 or 2 of these for each and try and work through some examples. And I'll come back to that later on. The white touched on many of these areas, and so it should be fairly easy for us to work at least 1 or 2 of these examples.
Great. Thanks, Maribeth. So these essential Arctic variables, they essentially guide observing system design in terms of what and how to observe, and more importantly, how to share those resulting data products. So this next slide is really a brief recap of essential Arctic variables using an example from the framework for ocean observing. If you looked at Hayo Icon's charge to working groups as well as Sandy's keynote, they expanded on this slide a bit. But for the example here, sea ice in a very broad sense can be thought of as an EAV, or more so as a process related to various things that the ice cover provides in the way of services or hazards. So what we're hoping to achieve in this AOS is not to actually step through a lot of the work that has already been done in societal benefits and applications, as like I'm stressing, much of this has been covered in prior summits, but we're simply trying to lay out what types of framework would allow large groups of people to do this jointly in an ordered fashion under the Say on Roads context. So in essence, for our goal for day 1 is to provide guidance on the process of, again, assessing what are the most impactful EAVs. And like I just mentioned, this can be CI, so it can be something else, while we critically evaluate what the potential societal benefits of that variable are. And then finally, what observations would be necessary to achieve those societal benefits. To facilitate and guide the discussion, we will have short 5 to 7 minute presentations from several persons that are already on this call. They all submitted contributions to our working group. Just to summarize, 12 white papers and short statements. Like I said, we received those for this particular sub-theme. And those submissions covered an amalgamation of topics and proposals related to the successful use of observing technologies, as well as multidisciplinary approaches to improve things like decision support, as well as risk management. Several papers also emphasize the urgency of expanding the reach of observing systems to support the scaling up of mitigation and adaptation strategies during the next decade, given projections of near-term climate change. And finally, one thing that I didn't mention, many authors really did stress the need for continued and improved engagement with members of Arctic communities. So with that overview, I'd like to pass it back to Maribeth for any comments, and maybe we can do a roundtable of introductions and give the presenters a 5-minute heads up that we'll begin presentations shortly.
Sure, thanks, Ravi. That was great. So I just like to, we're a fairly small group, so I think we can do like a 1-sentence introduction so we can get to know each other a little bit. So for those of you that don't know me, I'm Maribeth Murray. I'm the director of the Arctic Institute of North America at the University of Calgary. And I have been involved with the Arctic Observing Summit since the very beginning back in 2013. And I think we should just go down the list in order that I'm seeing them. So I will call next on Odile Krebeck. Do I have to unmute you, Odile? One sentence intro. Who are you from everybody?
Okay, hi. So I am your Zoom tech for today, but I'm currently a CIS researcher. I work at the University of East Anglia. I'm basically doing experimental CIS in biogeochemistry.
Great, Ravi.
Hi everyone, my name is Ravi. I work at the Arctic Institute of North America at the University of Calgary, and by training I am a geologist looking at the geomorphology of the Western Canadian.
Anne?
Hello, I'm Anne Garland, and I work for a nonprofit, Applied Research for Environmental Sciences, and we do a variety of different kinds of transdisciplinary research that's applied, but I focus on disaster risk reduction.
Great. Kathy Kuhn?
Yes.
There's two Kathys
Yeah, good
on
morning. Yeah, can you hear me?
Mhm.
My name is Kathy Kuhn. I work for a U.S. federal agency, the Bureau of Ocean Energy Management. I'm a marine ecologist by training, and I am the co-chair for the Circumpolar Biodiversity Monitoring Program under one of the Arctic Council's working group, CAF.
Thank you. Melina?
Hello, I'm a postdoctoral researcher affiliated with Dalhousie University in Halifax, Nova Scotia. And at the moment, I'm at Woods Hole Oceanographic Institution in Massachusetts. I'm a fisheries economist, interested in fisheries management and bioeconomic modeling, as well as in invasive species management.
Thank you. David?
Yeah, I'm with PolarView. We're a member-based organization with members across Europe and North America. We provide operational monitoring of the polar regions using primarily Earth observation.
Thank you. Dina?
Hi everyone, my name is Dina Abdel Fattah. I just finished up my PhD at the University of Alaska Fairbanks. I study sea ice and glacial hazards, particularly from a community context. And for today, I'll be presenting on some work that I did over the course of my PhD, where I spent a portion of my time at Stockholm University with decision and risk analysis modeling.
Excellent. Finn?
My name is Finn Danielsen. I'm an ecologist from a Nordic Foundation for Development and Ecology in Copenhagen, and I'm working with the practice and science of community-based monitoring and community-based management, and I'm currently working with the INTARAS Integrated Arctic Observing System project funded by the EU. Thank you.
Thank you. Gabrielle?
Hi, I'm Gabrielle Gascon. I'm a research manager with Environment and Climate Change Canada in meteorological research, and my group focuses on satellite, remote sensing, and ground-based meteorological observations.
Great, thank you. Helen?
Thanks, Mary Beth. I'm Helen Wiggins, Executive Director of the Arctic Research Consortium of the US, or ARCUS, which is a not-for-profit based in Alaska. And what we do is really facilitate collaboration for Arctic research and education.
Great. Jessica? Are you just gonna communicate with us through the group chat? Okay, Julie. Do I need to unmute? Let's go to Justin while Julie figures it out.
Hi everyone, my name is...
Oh, great.
Yeah, Justine Ramage. I'm a researcher at Nordregio. It's a research institute focusing on regional development and planning located in Stockholm. I'm a physical geographer, and I have done my PhD working with the impact of permafrost thaw on the release of carbon along the Yukon coast. And now I'm working in a European research project looking at the impact of permafrost thaw on the coastal population in different places in the Arctic.
Great, thank you. Caitlin?
Good morning from Alaska. This is Caitlin Mattis. I am a graduate student in environmental engineering in Colorado and Alaska, and I'm a rapporteur for the working group.
Great. Next, Kathy Law.
Hello, yes, this is Kathy Law. So I'm a Director of Research at LATMOS. It's a lab in Paris, in France. I work on Arctic area.
Great. And KK.
Good morning. This is KK Davis, and I'm in Fairbanks, Alaska. I am a recent graduate from UAF with an interdisciplinary degree in Arctic environmental policy, and I am really joining this summit as a citizen scientist or citizen observer. Thank you.
Great. Have I missed anyone? Michael, maybe?
Michael, I'm here. I'm a biologist working with community-based monitoring. I take part in the INTAROS project, and I will present a statement here on expedition cruises and monitoring. Yeah, thanks.
Thank you. And the last person I think is Margaret.
Sorry, I just joined. What are we doing?
Like one sentence intro.
Oh, hi, my name is Margaret Rudolph. I'm a PhD student at the University of Alaska Fairbanks, and I'm studying co-production of knowledge.
Great. Thank you very much, everybody. I hope I didn't miss anyone, did I?
One more.
Okay.
Mary Beth, this is
Matthew. Sorry, Matthew.
Oh, it's okay. It's a long list. I'm Matthew Druckemoner. I'm a research scientist at the National Snow and Ice Data Center at the University of Colorado Boulder, where I also co-lead the ALOCA program, the Exchange for Local Observations and Knowledge of the Arctic. Thank you.
Great. Thanks so much, everybody. So we have a nice diverse group here. We should have some productive conversation today. I'm going to turn it back over to Ravi to run the short presentations. Just a reminder, if you're going to do if you're doing a presentation, brief, please.
Thanks, Maribeth. So first up today, we have a phenomenal short statement that was submitted by KK. Again, these short statements are all available on the arcticobservingsummit.org website for you to peruse, to read. I strongly encourage you guys to do that as you also look at the synthesis white paper that we have written based on these. So KK will be given a short presentation on her submission that was titled Observing for Action, a Narrative. Odile, I think you may need to unmute your PC because we're not hearing anything.
I will start again the video.
Thank you.
And I will put my sound a bit higher.
The slides ahead are numerous and not necessarily my best photos. However, they will help one to better understand the complex behavior of the ominous cloud cover seen from Fairbanks, Alaska on an extra daily basis, with exception, of course. I would like to acquaint you first with the region from which all of my observations have been taken. You will see Fairbanks just about in the middle of the state, the Alaska Range to the south, and the gray highlight between Fairbanks and the Alaska Range represents the cloud cover that I have been monitoring for over 3 years now. It will be important to look closely at the horizon as I move through the slideshow. The photos in the upcoming slides are examples taken from observations spanning a period of time beginning in November of 2017. The first 3 slides are representative of what a typical subarctic winter day would look like in the greater Fairbanks area prior to November of 2017. For those of you that might be familiar with the poor air quality that befalls the city of Fairbanks on the coldest of winter days under the weight of an inversion, I will clarify that these photographs document a phenomenon separate from the air quality issues within the city limits of Fairbanks. The atmospheric conditions that I have captured in thousands of photographs span hundreds of miles at times and can be observed in other parts of the state as far south as Anchorage, but always arriving from the west. As I survey this cloud cover from morning to night, it has become obvious that the cover condenses throughout the colder evening temperatures, a concept known to be quite elementary in the scientific world of cloud behavior. As the morning sun rises and the air begins to warm, quite often the mass lifts, divides, dissipates, and breaks up throughout the day. In our darkest months, the sun cannot clear the mass on the horizon, or does so for only minutes at a time. This leaves some depleted of serotonin. Some days, as the mass lifts and moves, it can be seen landing on Fairbanks or surrounding areas. The color of this cloud cover misleads one to think that it is a storm cloud, but precipitation rarely presents itself from the gray mass. However, the most discerning quality is the color that so resembles a dense smog when it finally drops to the ground. When it lands, one has a sense of being in the clouds. And at times, it appears to be a mist or a fog, but the temperature may be around 0. This is not an example of what we used to know in Fairbanks to be ice fog, which typically occurs between 25 and 40 below. There's a great deal of information about Arctic low-lying clouds, to include ocean microbial cloud seeding, salt aerosols, and meteorological changes resulting from the reduction of sea ice during the winter months. It is the density and the odd color that I believe requires attention from the research community. The amplified and exaggerated color that is indicative of Arctic haze is often present and can be seen on days that the dark mass has dissipated or moved to the east. If in fact, this were transboundary pollution coupled with existing aerosols, how can these observations be tested in a timely manner? When and how does the research community decide to take up study? What stands in the way of a citizen observer bringing this to the attention of the research community, other stakeholders, and policymakers? The remaining slides show signs of pollution from wildfires, Arctic haze, and what these hourly changes can look like. I question what can be coming from these clouds dropping into our water and food sources. I long to return to the days of historical clear skies of Fairbanks and the beautiful horizons that I once knew.
Very good. Thank you so much, KK. Does anyone have any questions for KK based on her presentation? KK, if you're there, I do have a question. You mentioned in your paper that you've developed a better understanding of your role in sharing observations. Do you see that as providing a platform for change?
I'm actually not so sure how to answer you, Ravi. I do see it as a platform for change. I'm not exactly sure where to put the hooks,
Okay.
as I have not been successful in bringing this to anyone's attention thus far.
Do you have any reasons why that might be? Is it that people do not place an emphasis on citizen science, for example?
That is what I have gathered in my reaching out to several stakeholders. It's not that it hasn't been noticed in the community, but the reception in sharing these observations with other various stakeholders had various response, and I honestly, I'm hoping in our discussions during our working group, maybe we can discuss what those responses really mean.
Okay. All right, thank you so much, KK. If we have no more questions for KK, I'm just going to leave it open for about 5 seconds. Okay, so next we have Gabrielle Gascon. And Gabrielle also submitted a white paper that was extremely informative on leveraging existing sites for meteorological observations to support search and rescue operations in the Arctic. So Gabrielle, over to you.
Thank you, Ravi. So just give me a second and I'm going to be sharing my presentation. Are you able to see the slideshow?
Yes.
Okay, perfect. So for those of you who attended the poster session earlier today, this short presentation will build up on what I presented, and we'll look at how we can leverage existing sites for meteorological observations to support, for instance, search and rescue operations in the Arctic. So weather is a safety issue for the Arctic with hazardous conditions including blowing snow, blizzard, fog, or extreme cold. Based on a study from Statistics Canada, a disproportionate number of search and rescue, also known as SAR, incidents occur in Canada's northern territories relative to the southern provinces. This is primarily due to a greater proportion of human activity in remote northern locations, combined with frequent hazardous weather conditions. On the left, you can see how the major storm tracks, so the large yellow arrows, intersect with the different types of marine transportation routes. The city of Iqaluit in Nunavut is a hub for shipping and transportation and is shown by the red circle. If we then focus on Iqaluit, the second most common weather event between 2016 and 2018 was blowing snow, often in the form of blizzards. These blizzards can affect navigation, safety, and mobility for SAR operations in the Arctic. As population, economic development, and tourism continue to grow in the region, demands will be placed on transportation and SAR-related infrastructures and services. The deployment and safety of SAR operations may be compromised by extreme weather conditions, creating an important need for the accurate monitoring and prediction of Arctic weather. So Canada's Northern Strategy is all about creating a greater presence in the North and building sustainable communities. One initiative is the establishment of enhanced meteorological observation sites in order to test new technologies for the monitoring of atmospheric conditions. The sites are located in Iqaluit, Nunavut, and Whitehorse, Yukon, as part of the Canadian Arctic Weather Science Project, referred to as CAUSE for the remainder of this presentation. Each site is equipped with state-of-the-art instruments providing a wide range of near real-time meteorological measurements. To date, the CAUSE project has been scientifically driven, providing enhanced meteorological observations during the World Meteorological Organization's Year of Polar Prediction, observations for meteorological process studies, and infrastructure to conduct research into future operational monitoring and forecasting programs in the Canadian Arctic. So here's currently how CAUSE data is used. We take Arctic in situ observations. Scientists use the data for evaluation of weather forecasts, for example, development of new weather forecast applications, and research into the future operational monitoring and forecasting program. So here we have a link to theme 1 of this Arctic Observing Summit in terms of design, optimization, and implementation of the observing system. Both the observations and research and development outcome are used in that center box to support informed decision by our weather forecasting program, who will then either emit public warning and alerts or contact specific stakeholders, SAR, and community directly. This framework is currently applied in the context of experimental hazardous weather forecast products for visibility, blowing snow, and fog, and has been used to support our, in Canada, our operational weather forecast, the Department of National Defense, North Pole expeditions, and it's actually already supporting search and rescue operations. So the figure on the left shows an example of a blizzard forecast product over the Iqaluit area that was evaluated and developed in part with the CAUSE data. This is an inlet for Iqaluit, but the product is actually available for the entire Canadian Arctic. But there is the potential to more by leveraging existing scientific activities revolving around Arctic observation sites, such as the CAUSE, to support navigation, safety, and security in the Arctic, including SAR observations. So let's have a look at a revised workflow as to where we would like to go in terms of planning our activities. So we have all these observations that have been, for the most part, driving a scientific agenda. Through research, existing research and development activities, and in addition to what was previously mentioned in gray here, there is the opportunity to incorporate the evaluation of the awareness, use, and suitability of hazardous weather forecast and warning information, noting that this is something already done in all or part in numerous national weather services. There's also the opportunity to evaluate the use of forecast for decision-making for targeted users and stakeholders, including SAR, and to develop strategies to integrate traditional Indigenous knowledge with the scientific information to meet the needs of local community. So this new information back to the box, the center box, is then used to support the informed decision-making by our weather forecasting program, who will then emit more targeted warning and alerts and weather information to specific stakeholders, SAR, and communities. So as a take-home message for our road to success for this is tailoring meteorological information to users and stakeholders is a value-added service that's essential to maximize a weather forecast effectiveness at influencing preventive behavior among those at risk in the Canadian Arctic. And the key for success will be to develop a mechanism to successfully integrate and balance what is scientifically possible and technically feasible with what is socially desirable and supportive of Indigenous people and communities, Northerners, SAR officials, and local governments. So with that, I thank you very much for your attention.
Thank you very much, Gabrielle. I'll leave the floor open for any questions. Again, feel free to pose questions for any of the presenters in the chat, or you can use the raise hand function, or you can just wait until the presenter has concluded their presentation. Okay, if there are no questions for Gabrielle, we will move on next to Dina. And again, Dina, as well as her co-authors, wrote a phenomenal short statement looking at the use of multi-criteria decision analysis in understanding Arctic change in a cryosphere context. So over to you, Dina.
Great. Can everyone see my presentation?
We can.
Okay, wonderful. So I will just in brief summarize our short statement that is available on the website. But in sum, my name is Dina, as I mentioned. I'm at the University of Alaska Fairbanks, and I worked with Love Eckenberg and Aaron Larson at Stockholm University. And there we looked at how we could apply a multi-criteria decision analysis framework into understanding Arctic change, especially in a cryospheric context. So this presents an interesting opportunity for us to discuss in the context of the climate change crisis, perhaps the opportunity for innovation amidst everything that is going on. Complex problems associated with climate change also need novel applications to address them, given their complexity and cross-cutting nature. Interdisciplinary research, particularly between the different sciences, be it physical, social, or computer science, can potentially help to utilize the strength of each of these disciplines to together address the complex problems that are associated with climate change. And just for some background, my own self, I'm both a social and physical scientist, but my collaborators at Stockholm University are computer scientists. So for the idea that we had and what we worked on doing was taking a field in computer science, decision and risk analysis, and trying to see if we can use the well-established nature of it, as well as the different frameworks of application that has been used, to see if we can maybe apply it in the Arctic context. Thus far, as I mentioned, decision and risk analysis is a well-established field, particularly from a modeling perspective, but there's limited application in Arctic decision contexts, and more particularly regarding the cryosphere. So thinking about how we can take the lessons learned from applications in other sectors, and also from further developing this field, there can be mutually beneficial applications of applying decision and risk analysis in a novel context to help further our understanding of the environmental, social, and economic possibilities that need to be taken into consideration, but also to develop the field to be better capable to generate outcomes given high uncertainty and limited information, which is essentially the context that we're operating on sometimes regarding Arctic climate change. But there's obviously challenges in doing so. Decision and risk analysis places great emphasis on weighting and also understanding how different variables relate to one another. And in doing so, you can sometimes lose information by focusing more on the weights than their actual content. So there's different types of methods that can be used, whether it's criteria, ordinal rankings, that can basically look at variables in relation to one another rather than as static, simplified numbers. And further, there's new methods that are being developed to utilize direct inputs, so qualitative information from decision makers, to then inform and also do so in a systematic way that can be used over time. So it's a way of merging both qualitative and quantitative studies. But nonetheless, possibilities for misinterpretation remain. So as I mentioned previously, it's really important to also not only focus on these numeric values in the models, but to also include information on relational strengths to ensure that the whole picture is being captured. So for the purpose of this work, we looked at applying multi-criteria decision analysis into glacial lake outburst floods, especially regarding their community impact and their social and economic impacts on communities. And we're looking at it from the possibility of mitigating flood events. So what are the different strategies that can be used to mitigate the effects of these criteria will ultimately be used to then develop for mitigation strategies. So that's how these can be. There's someone.
So, but it's there. I'll put it.
Thank you. So we're looking at basically how these 3 to 4 mitigation strategies will range from low to high effort for decision makers, and from a perspective of both economic and human resources in terms of the effort that needs to be put into these strategies. Also looking at how they can potentially be involved in several different scenarios. So whether it's a small flood to a large flood, and how that ultimately relates to these different strategies that we propose. And as I mentioned, it's important to look at the qualitative information. So in terms of the variabilities and their feasibility and sensitivity, and also the conflicting stakeholder interests that could arise when you're looking at these different mitigation strategies. So I did most of my PhD research on Gulf events in Juneau and on the Kenai Peninsula. So via those, I have a large set of qualitative information that is collected on these 2 communities. So beyond that, and the relationships that we have that exist, we will be using that to inform the feasibility of these mitigation strategies that we are considering. And this is just a brief note, but as I had mentioned, the well-established nature of this field, these are a few other contexts, though they're not in the Arctic or regarding specifically climate change, but they look at the different stakeholder conflicts and interests at play regarding complex questions and decisions. So whether it's energy security concerns, humanitarian demining, or looking at stakeholder interest in a gold mining project, these are a few examples if you're interested in learning more. Thank you.
Thank you very much, Dina. Does anyone have any questions for Dina? Dina, I know that you just mentioned this, but I do have a question that someone sent. Do local experts and perhaps community monitors contribute observations about these hazards for their communities?
In the Alaskan context that I mentioned? Or in general?
In general, I guess. They didn't specify.
Yeah, I mean, I think that's definitely a possibility. This is, as I mentioned, the mutual benefits of perhaps working with Arctic communities with these more model-based decision-making tools. Normally they look at interview data, so that's something that they do with decision makers, and then various different economic and social indicator information that is available online are collected. But there's growing room to incorporate different knowledge sets and information sets. So I think that would be a really great opportunity to apply community-based knowledge in a way that is systematic and can help decisions ultimately.
Okay, great. Any other questions for Dina? If not, thank you very much, Dina. Next, we will move on to Kathy's presentation. And Kathy submitted a white paper titled Arctic Air Pollution and Society. Kathy, I think that you're on mute.
Can you hear me?
We can, yes.
Okay, great. Yeah, thanks. So we submitted a short statement on Arctic air pollution and societies. So this is an initiative that we've been spinning up under several initiatives, but mainly under PACES, which is a kind of umbrella initiative under IASC, but also under the Future Earth IGAC project, which is on atmospheric chemistry. So we're interested in looking in particular at local sources of Arctic air pollution. Traditionally, people have been looking at the effects of air pollution on climate. So this is the transport of pollutants from mid-latitudes and their effects on, well, producing phenomena like Arctic haze that KK already mentioned. But what we're seeing is that the Arctic is already being affected by local sources of Arctic air pollution. And of course, this can impact both human health and pollution can also be deposited onto ecosystems and have effects that way as well. So there are a whole variety of different sources of pollution. And to simplify matters, I'm just going to mention that essentially we have wintertime pollution, largely from combustion sources due to increasing needs for heat and power when there are very cold temperatures in the winter, combined with stable meteorological conditions, which trap the pollution near the ground. So then you can also have, increases in air pollutants during the winter, particularly in urban areas. For example, in Fairbanks that KK also mentioned. And this can also lead to increased deposition of pollutants as well at this time of year. And then during the summertime, of course, we have boreal forest fires, and these can also be a large source of pollution. But in fact, although we have kind of monitoring sites around the Arctic and also some measurement sites in urban locations, there's really still quite a lack of even basic data on the types of pollution and our fundamental understanding about processes leading to, for example, the enhanced pollution during the winter months. We don't really understand the chemical processes which are going on to produce some of this aerosol pollution because it's dark, it's very cold. So this is something that we also want to understand. So there is a clear need for more observations. We would like to also try to include, or we are starting to include, more observations carried out by local communities as well. And I would just highlight that we published a paper on this in 2018 in Earth's Future, kind of outlining some of the issues. So in terms of where we are with this initiative, the kind of current status, we're trying to build this as a transdisciplinary and initiative and also covering multiple scales. Of course, if you live in a city, then this is a kind of local scale. But then if this is happening in several locations in the Arctic, we want to be able to compare different places and get more of a feel for how this might be impacting the Arctic, how local pollution may be impacting the Arctic on regional and perhaps also Arctic-wide scales. And so one kind of avenue that we've been working on recently is more of a focus on what we're calling northern urbanization under environmental and climate change. And by urbanization, we don't mean that urban areas are necessarily going to increase everywhere. There are obviously areas in the Arctic where urban populations are decreasing, and also we recognize that there are a range of different sizes of settlements in the Arctic. So there are Arctic cities, quite large conurbations or urban areas, particularly in northern Russia. But of course, in other areas, there are settlements of all kinds of different sizes. So to date, we've been actually focusing mainly on Alaska. We have this initiative, this project called Alpaca, looking particularly at this wintertime pollution issues. And we started to make some rather detailed measurements there last winter, and there's hopefully going to be a big campaign, measurement campaign there next winter. So this is being led by Bill Simpson at the University of Fairbanks, Alaska. And then on the broader Arctic scale, we're trying to link to other initiatives. So not only PACES, but also linking to the PEAKS, the Pan-Eurasian Experiment, what we're thinking of is to try and build something under an initiative of the WMO. They have an initiative on urbanization where they have what they call city pairs, this twin city approach, where they're looking at enhancing observations, for example, in terms of looking at meteorology, but also pollution, with the aim to improve adaptation and mitigation to reduce risks to populations in city environments. But in fact, they don't have any, currently have any, anything going on in the Arctic regions or for northern cities. So they're very keen to build something in the northern Arctic regions as well. So we've had a workshop in Helsinki in January, where we tried to really emphasize this, the Eurasian side of what we're interested in. We've already identified some cities where we may be able to do something. And this is also building on, for example, in Russia, there's been an initiative looking at urban heat islands. So when it's, you know, the kind of heat coming from local heating, domestic heating, is producing heat island effects in cities in Russia. And we hope to be able to build on this, particularly using small sensors that can be used not only by researchers, but also more widely in the communities. And I've got an example of that on my last slide. But just this slide is kind of stepping back a bit, just to say how I think what we're proposing can contribute to the societal benefit areas. I think our idea is that we would hopefully build up observational capacity in different locations, and this could inform decision making relevant to certain SBAs like human health, environmental quality, weather and climate. And in the Helsinki meeting, we also discussed the links to the UN SDGs as well. And then we probably need to think about this a bit more, about which essential Arctic variables we could think about. Of course, we can think about air pollution measurements, but it would be good also to think, I think, as Ravi outlined in his introduction, about how under that you have variables which connect to the SBAs. So for example, toxicity would connect to human health. In terms of observing capacity, as I mentioned, there are already existing measurement sites, but there are also some kind of more community-based networks, such as this Purple Air network, which I've shown you a map for Alaska on the top right. So there's a whole series of sensors which are being operated now, and you can get data in near real time. Of course, there are quality assurance issues that we have to think about. But this is certainly an interesting way to move forward in terms of co-producing observations with communities. And there may also be room to expand to other pollutants or contaminants as well, not only air pollutants. And then something else, just my last point that we discussed in Helsinki is that we discussed the fact that adaptation and mitigation measures, of course, they need to be based on sound science where possible, and taking into account, an important point is to take into account local knowledge as well. But an important issue is that they need to be relevant to the Arctic. They need to be Arctic specific, because they have to be relevant to Arctic specific conditions and also effects. So for example, people may not be responding to the health, if the impact on people's health from air pollution may not be the same as mid-latitudes. And this is something that, well, we're atmospheric scientists, so we would like to work with people in the health domain, for example, on these aspects. Okay, so I'll leave it there. Thanks.
Thank you very much, Kathy. We really encourage everyone to have a look at Kathy's paper, as like she is showing on that last slide, the essential Arctic variables and the SBAs were clearly identified. So we look forward to your input in our breakout sessions and discussions, Kathy. We do have one question for you. Does this also measure pollution related to wildfires?
Yes, I didn't mention that, but actually there's a project that's we can't say too much about it, but it looks like it's being funded. So an international project looking specifically at forest fires and linking to community measurements. So yes, there is definitely going to be an angle on forest fires as well.
Excellent. Do we have any other questions for Kathy?
Kathy, this is KK Davis. My question is the measurements that you plan to take. I think you said this next year, within this next year, will those be just from the city of Fairbanks then, and that problem in itself, or surrounding areas as well?
So as you may know, there's a project that's been funded by NSF called SnapTech, which Bill Simpson is leading. So this has a focus on indoor and outdoor pollution in Fairbanks. But then there are other groups. For example, in France, we're planning to participate, making measurements not only in Fairbanks, but also at Poker Flat. And other groups, international groups, are also planning to come making measurements not only in the city, but also around the city and outside the city as well. So also looking at Arctic haze and not just looking at the local pollution.
That's great. I'm hoping in the remainder of our discussions that we might touch down on this just a little more. I'm curious how to make the connection from for instance, my observations to the people that may be taking these measurements, and how I can help to just make connections there.
Yes, I was very interested by your presentation, and I didn't ask you a question directly because I was kind of trying to think, you know, how your interesting observations could be linked to the kind of measurements that we're planning to make, or which are being made already. But I think there's certainly some interesting angles that we could think about linking your cloud observations together with aerosol measurements. I think that could be something that could be interesting.
Okay, thank you, Kathy and KK. If we have no more questions for Kathy, we would like to move on next to a presentation from Joseph Little. Joseph, together with his co-authors, wrote a white paper titled Bridging Organizations to Support Researcher Recommendations and Tackle Unresolved Societal Value Assessments for Sustained Arctic Observing. So Joseph, if you'd like to share your screen.
Yeah, thank you, Ravi. Good morning, everybody from Fairbanks, Alaska. Thank you for having us. This is an exciting opportunity. I hope this finds you, stay finds you well and healthy. Yeah, so working with Olivia Lee and Helen Wiggins, we're looking at bridging organizations to support researcher recommendations and tackle unresolved societal value assessments for sustained Arctic observing. Noticing that last question with the need to coordinate research and the potentiality of researchers identifying new networks, the spirit here is that bridging organizations provide important infrastructure that can be used to support sustained interdisciplinary research coordination. And so the basics, when we look at this, would involve assessments of not only networks, researchers and interdisciplinary scholars, but also providing the basic transactional reduction in costs that we see associated with workshop logistics, scheduling meetings, report writing and support. Also developing long-term archives of observing recommendations, and then a number of outreach communication support tools that become prevalent. The white paper focuses on the Arctic Research Consortium of the United States, but there are a number of bridging organizations throughout the Arctic that can be used to serve this infrastructure support tool. One of the advantages is that it actually accentuates and strengthens communities of practice and allows them to develop. In many instances, we go and pursue funded research on a disciplinary approach. This research is successful, but it doesn't have a long life because we don't have the mechanisms to carry on the findings or the work after the life of the project. Some of the major advantages of bridging organizations and the purposes that they can serve is that they can help reduce the transactions costs associated with coordinated research. And so providing meeting logistics, such as we're going through today, report preparation for output, and then outreach communication support is becoming increasingly important in our interconnected world. Also, we use bridging organizations to preserve institutional memory. As we mentioned before, disciplinary research projects sometimes come to a close before their time. Bridging organizations can help extend those efforts and make sure that they extend the life of previous collaborations. And so in this way, while funded projects might come to an end, their capital that they develop remains in place and can be used for future research efforts. Finally, we also look at developing more complicated social assessments as we move forward with interdisciplinary and transdisciplinary research for that matter. The need to fully integrate Arctic stakeholders into the research effort. And so this networking and engagement with the Arctic stakeholders is becoming increasingly important as we're depending more and more not only on traditional knowledge, but also Arctic observers to actually track in real time changes that we're observing in the Arctic. And mentioning the SnapTech effort just previously and being here in Fairbanks was familiar with the air quality issue. The SnapTech effort's distinct because it will help coordinate a number of different dimensions of research on the air quality front here in Fairbanks involving stakeholders. And so this is the type of work that bridging organizations can help facilitate and also encourage. Finally, the important dimension that I don't want to forget mentioning is the societal need for Arctic observing as well. And so stakeholders have a vested interest in expressing what their needs are for observation. And so as they reach out to researchers and vice versa, that these researchers are also orienting their efforts around observing stakeholders. So the sense here is that the bridging organizations provide an important purpose in extending the life of research collaborations, extending networks and coordination efforts among researchers, and also identifying new pathways to integrate stakeholder input and preferences for research outputs into the research paradigm. And that is what I had today.
Excellent. Thank you, Joseph. Any questions for Joseph?
Yes, this is Kathy Kuhn, and I do have a question.
Yes.
Thank you for the presentation. How would you think it feasible to really do good networking and engagement with Arctic stakeholders? And I guess my two thoughts are, is it a set of in-person, visits to communities, or having some sort of online, portal that perhaps the communities themselves develop? We're kind of in Alaska specifically, we're always in this crux because we want to engage our Arctic stakeholders, in particular the coastal communities, but they want to be part of the solution on how the engagement occurs. And have you put some thought into different ways that might be effective?
Yeah, that's a fantastic question. Thank you very much. And so just using the Alaska setting and the Alaska experience to kind of contextualize this. First off, with the question of how to execute it, I think in-person is incredibly important, but I also think that you need to have online presence and a setting where people can communicate over great distances to handle just the basics associated with size of the geography that we're typically dealing with. And so from that standpoint, having an accessible and knowable portal that Arctic stakeholders that can engage through is a critical element, I would argue, of bridging organizations. If you were to look at the ARCIS website, that's one example. At the International Arctic Research Center, we also have AOK, or the Arctic Alaska Observatory Knowledge Hub, which helps coordinate ground stakeholders or Arctic stakeholders in Northern Alaska. And so from those dimensions, they have the capabilities to actually communicate through apps, for example, but they also have in-person meetings and coordinate very frequently with individuals at the research center here. Now, other dimensions I would argue that help facilitate that engagement isn't just the in-person component, but also the co-production of knowledge and actually finding time to develop new research ideas that are truly focused on Arctic needs. And so from that standpoint, the NNA effort is one positive step forward, I would argue, but making sure that co-production of knowledge is genuinely co-produced between Arctic stakeholders and researchers is going to be an important dimension. And so having those networks in place beforehand can help facilitate that early development of co-produced research efforts.
Thank you very much. Perhaps we can engage with each other even after these meetings.
Yeah, I would enjoy that. Thank you very much.
Okay.
Thank you, Joseph and Kathy. Do we have any more questions for Joseph before we move on to Anne Garland? Okay, so if not, we have a presentation from Anne Garland next, and Anne presented or submitted a white paper on Arctic Risk Management Network. So Anne, over to you.
Thank you. Can you guys see?
We can, yes.
All right. All right, so we did do community-based monitoring for coastal erosion in Utqiagvik, sponsored by Applied Research Environmental Sciences nonprofit, along with this group of wonderful collaborators, including the emergency manager, whoever that happened to be since 2015 to last year. We'll be continuing as well with a NSF NAA project. Just a little bit background on who we are, just to point out that we do have every project involving applied research, public education, or outreach, and a whole concept of applying it to community-based decision-making. So that started us with working initially in 2006, I started working with Homeland Security Center of Excellence called CREATE. And we started this project called Working Together for a Safer Tomorrow, in which it was focused on tribal inclusive geographic areas. And these gives you an idea of the target goals that we had for those 10 years. And I worked with quite a few different tribal emergency managers in that time. And that's how I ended up getting to the Arctic and implementing some risk assessment workshops and tools that we were developing as far as multi-jurisdictional cooperation across tribal and non-tribal communities related to, sharing and cooperation, resources, services, and capabilities. So that's how I ended up in the North Slope Borough back in the IPY year. So I've been working with the emergency manager or the risk management office there for quite a long time. And we expose them to several tools to help them raise awareness for cooperation. And this last tool, which is the Arctic Risk Management Network, is what we're featuring right now going forward in the Arctic to try and help solve the facilitation of hazard research to practice and share mitigation strategies. And we're also developing an ecosystem map of resources and trying to help them with research gaps, since their expertise and funding are always at a disadvantage. So when we started in Utqiagvik with this concept, we decided to use something called historical ecology for risk management, use sustainability. And we started that in 2013. So I've been going up there every summer since then working with emergency managers and the community, trying to figure out what it is that are their priorities for disaster risk reduction. And of course, the very thing on top of the list at the very beginning was the coastal erosion. Obviously, you can read the variables that are involved in that. They were very much aware of that, but they had no resources to study it. Just a little background on what historical ecology is. I'll let you read most of this slide as you will, but the whole idea is a transdisciplinary approach across different sciences and always integrating stakeholders and users from the bottom up and deciding on what you're going to be studying. So we started out with this concept of historical ecology, which can be applied for many different things. We're just happy to be using it for hazard mitigations. But we also tried to include the next generation in our modeling. So we asked the school district if we could apply the Inupiat learning framework to our concept of historical ecology. And so we came up with what you see at the bottom is their graphic image of that framework. And we developed this just to help people when we do presentations understand that connection and how we're doing similar kind of transdisciplinary work in different sciences, as well as applications to mitigation and preparedness. But the long-term coastal erosion studies, we're not the only ones that are, of course, doing this. There are a host of people, and we've partnered with as many as we can. We try and stay networked as much as we can, including with the BAID group. They've partnered with us over the year and vice versa. Their focus is mostly natural science studies, but they did do some mapping of the shoreline through the city area. So our focus, of course, is on critical infrastructure in the community. So our focus on community-based monitoring is actually the shoreline, the cityscape, and how the coastal erosion and the surge levels are impacting infrastructure. And some of the efforts to try and protect their infrastructure, as most people know, are failing. Some of the seawalls are collapsing and require repairs. The shoreline armoring that is being done in Utqiagvik, the sacrificial berms continually dissolve and erode away, have to be rebuilt with super sacks. Revetments are collapsing now as of 2018. So the variables for coastal berm and bluff erosion are constantly escalating. You can see their Barrow Hazard Mitigation Plan in 2004 that shows even back then what they considered detrimental along their coastline as far as threats and impacts. So we finally, after doing this since 2015, with mostly donations and cost share, whoever could help us, we finally got some funding through Alaska Sea Grant, and we're able to expand this whole concept of linking practitioners, researchers, and participatory action with community monitors, specifically for erosion surges. And also, we're also experimenting with surge levels now with this funding, and we have landmarks. You can see in the center picture there, we have surge heights. We're able to record with that landmark. Those actually are boat ramp uprights that we have marked and benchmarked so we can take pictures. And that's helping tremendously with the data collected to validate the software for forecasting with our colleagues at UIA, the Arctic X Beach. And one of their master's thesis is presenting tomorrow on that project, actually. So we're really happy that we were able to achieve that, that benchmark or landmark for this project. We also are very fortunate in this project to have a link with Alaska Coastal Hazards and Jackie Overbeck, who I've been working with for years, so we can get this data out, have it accessible based on community protocols of accessibility for their information and profile mapping, so others can take advantage of this data. So this is going to probably go live in the next year. She's still working on trying to create us a web page on her site. So this is just an idea of how we train the citizen scientists and some of the variables that we ask them to do and what we ask them to do and how long we ask them to do it. I have a fantastic group of about 10, it depends on the season, but 10 to 15 monitors. So we try and only have them do monitoring in a particular transect. As listed here, we have 7 critical areas of the beach that we're monitoring. And we also do, along with the survey, we also do wind, waves, and weather, and also some geotechnical information. As you can see, we also have started a new concept with a Go Green Challenge, a berm plant study. And that has become very interesting. We've gotten to the point of taking pictures of it constantly since 2014, that the coastal berms there's a natural migration of tundra plants to it, as you can see in this picture. And we are desperately trying to study that now. We actually have one of the monitoring families who's doing as a homeschool project so far, but we'll be continuing this with the NAA money and expand it to see if that can actually help stabilize that gravel, silt, sand from an inland source. And it seems to be coming back regularly in certain areas along the coastal berm. We've gone to the point of being able to ID them now, and we're going to be working on a next plan for next season, if we ever get up there. And if I don't get up there, at least I have my community monitors who can help carry on this work, because they're absolutely fantastic. And then lastly, we do have an initiative for harmful algal blooms that we started in 2016 with community monitors using the phytoplankton monitoring network with NOAA. And we are working with Don Anderson as well, letting them know what we have found and what they're finding through their research with NSF, the Woods Hole Oceanographic Institute. And they have, as I point out in this slide, have identified the toxic species that produces saxitoxin in those locations listed there in the Beaufort and the Chukchi. So while we're doing near shore and lagoons, I am also trying to stick with the AHAB group. They're starting a freshwater lagoon study, or freshwater system HAB study, actually in our first, I think our first teleconference is this week. So we are trying everything we can with community-based monitoring, because it's really it's the wave of the future. We have to keep the community involved with their own needs, and also help them do the research themselves that can contribute to decision making. And any questions?
Thank you so much, Anne. This is excellent work. Any questions for Anne? This might definitely be an essential Arctic variable in terms of coastal erosion that we can expand on. But again, that's up for discussion. Next, we have Matt Druckenmiller, and he's going to be presenting on a paper or short statement that was submitted focusing on advances and applications for landscape scale coordinated monitoring networks. Over to you, Matt.
Great. I will share my screen, but I think it requires the previous. And if you can stop sharing yours, I think I can.
Yes.
Yeah.
Share mine.
There.
Great. Thank you.
Sorry.
Okay. Am I sharing well?
Yes, we can see you now.
Looks good.
Okay. So thank you for this opportunity to present during this session. This is a summary of a short statement that describes a new Navigating the New Arctic Track 2 award. So many of you may know that the Track 2 awards from Navigating the New Arctic are not research focused, but are rather focused on building community in many ways. And so this presentation will talk about our efforts to advance applications for landscape scale coordinated monitoring networks in Alaska, Northwest Canada. And I should say that listed here are the contributors to this short statement. And Leanna Hefner with the Northwest Boreal Landscape Conservation Cooperative is serving as the PI. But the group that we're working with in this, our full range of partners and collaborators is quite extensive, many of which are listed here, although this list is not entirely complete. And so I show here the region that this project is focused on, and we have since retitled our project to a much shorter name of Northern Connections. And so we're focusing on Alaska, Northern British Columbia, parts of the Northwest Territories, and much of the Yukon, recognizing that there's little coordination or connection across the community-based monitoring projects across this very broad region, and that many are limited in their ability to gather data, to share data, and to a large extent that's due to logistical constraints, but also certainly constraints related to just the capacity to manage community-based monitoring. And certainly there are also critical gaps in data and knowledge. Certainly I think many that relate to this idea of essential processes. And so if you think about monitoring on the landscape scale, that intersects with critical issues around migration corridors, watershed dynamics, land use planning, invasive species, and many other issues that I think really need to be considered at the landscape scale for an effective integration with ways in which policy and decisions are made. So I list here three of the overarching objectives for this project, which just started this past November, and it will be running for approximately the next 2 years. And so first, we're looking to explore options for developing coordinated monitoring networks, to identify what the integrative research questions may be, what the critical gaps are there certain regions that may lend themselves for better coordinated efforts than others. And then secondly, to create and implement strategies for tackling commonly shared challenges. Many of these relate to logistical constraints, the lack of capacity and expertise, and largely just the lack of connectedness across the region. And then finally, one of the core objectives is going to be to develop an educational curriculum on landscape scale community-based monitoring best practices. We're not aiming to implement a curriculum, but simply to develop it. The overarching desired outcomes from this project are listed here. The first, which is to foster development of at least one landscape scale coordinated monitoring network. Secondly, to be very specific in supporting Indigenous-led monitoring efforts. That's a key priority for this group. Many of the partners involved, if not most, are already Indigenous-led monitoring efforts, but those are certainly the ones that we want to prioritize. We're looking to advance how the monitoring results are used in decision-making processes around sustaining traditional ways of life, community resilience, land and resource management, climate change planning, and engineering, as well as hazard mitigation. And so I really appreciate hearing about Anne's project just a moment ago. And lastly, we're very much focused on just simply fostering cooperation, knowledge sharing, and building trust across the communities and different institutions and universities that are working across this region of Alaska and Northwest Canada. One of the ways in which we are organizing ourselves is that we are creating a number of working groups, And I say here proposed because we are hoping that our first major work session, which was supposed to happen in a couple weeks, but it'll be now postponed till the fall. That first meeting is where we are really hoping to refine these working groups. But our initial proposed list is to have one focused on data management and technology. And this relates very much to the organization that I work with, which is ILOCA, Exchange for Local Observations and Knowledge of the Arctic. To have a second one on indigenous and local knowledge, a third on co-production of knowledge, another on climate change adaptation, one that's really focused on bringing the results to those that can use those. So applying, synthesizing, and communicating the results from community-based monitoring. Another will likely focus on building capacity and recognizing that a big part of that is ensuring that programs have the necessary funding to sustain local partners, to get up and running, and to continue into the years ahead. Funding is very often a critical limitation for community-based programs, and certainly for integrating across a larger area. Within the community that we've been working with, there is an interest in furthering the community-based monitoring atlas, which Nora Johnson and others had developed as a contribution to SAON. So we're wanting to build upon that, focused on the region of Alaska and Northwest Canada. And then lastly, to have a working group focused on developing a curriculum. And I'll simply end again by mentioning that we do intend to have a work session in the fall, likely September 2020 in Anchorage, Alaska. This will be a 3-day session with approximately 50 participants. And the goals are to really begin to build the community, to network and share, but more importantly, perhaps, is to really refine the focus topics of the working groups that I just presented, and to provide them with a foundation of knowledge and expertise, identify the leadership, and then to develop goals and a plan for their regular meeting in lead up to our second work session, which will take place in 2021. So with that, I welcome anyone to reach out with ways in which you might be able to partner with our group. Our hope is that we will have some substantial results for Arctic Observing Summit in 2 years. So thank you very much.
Excellent. Thank you so much, Matt. Do we have any questions for Matt? So Matt, I do have a question for you that was sent. It says, in your experience, is the lack of coordination or connection between monitoring programs resulting in substantial gaps in data and knowledge?
Well, I think as I briefly said, that to really be able to move the ball on how we are applying the results from community-based monitoring, I think the connectivity on the landscape scale is important. That's not to say that individual community-based monitoring projects are, that there aren't plenty of examples of programs that are very comprehensive and detailed in what they've observed over the years. But to really achieve relevance to issues around migrational corridors, a lot of the issues in the marine environment with increased shipping, kind of large scale issues around pollution, contaminants, invasive species, I think that there is an interest and a need for that greater connectivity on the landscape scale, and to have that connectivity bottom up as opposed to top down.
Right. Because the truth is, you do have several players that are leading different initiatives in the Arctic. And there was a comment, I believe, that the result of that is we are not leveraging or even using the lessons that we are learning because of so many different interconnecting initiatives that are taking place at the same time. All right, any further questions for Matt? Great. Thank you again, Matt. Next, we will move on to a paper that was submitted by Irina, Monitoring System to the Energy Security Threats of the Arctic Region. So over to you, Irina.
I'm not sure if she's here.
I'm just looking, she's not.
So why don't we move on?
All right, Tom Barry, or any of the co-authors for the paper Statement to the Arctic Observing Summit. There we go.
Yeah, hello, this is Kathy Kuhn. Are you able to see my screen?
We are, Kathy, yes.
You just need to blow it up.
Okay, let me get in presentation mode. Okay, well, good morning from Alaska. My name is Kathy Kuhn, and I'm presenting on behalf of my co-authors, and we'll discuss one of the Arctic Council's working group, Conservation of Arctic Flora and Fauna's key monitoring programs, and that's the Circumpolar Biodiversity Monitoring Program, and that's been in existence since about 2008. The Arctic Council is a consensus organization, so nothing compels participation by Arctic states. However, there is broad participation in the CBMP group, and that's sought to facilitate more rapid detection, communication, and response to significant biodiversity-related trends and pressures affecting the circumpolar Arctic. The CBMP is an international monitoring network of networks. It's comprised of international group of scientists, governments, indigenous organizations, conservation groups, working to harmonize and integrate efforts to monitor the Arctic's living resources and aims to incorporate traditional knowledge from its holders. It aims to interact societal benefit areas of better understanding ecosystem processes across the marine, coastal, terrestrial, and freshwater ecosystems into applied use for decision makers and the communities that are part of the ecosystem. The CBMP is a focal point for current and credible Arctic biodiversity information, includes the status of focal ecosystem components, which are key indicator species. These, I suggest, might be viewed as essential Arctic variables, which provides a mechanism for progress of knowledge and implementation. Some of the challenges of CBMP include the support of experts' time to engage in these CBMP network activities, and also the concept of including traditional knowledge holders. We're also in a point of trying to better look at the abiotic and the biotic together. And we have some examples of this where the CAF working group of the Arctic Council is trying to work with another Arctic Council working group that focuses on the abiotic, and that's the Arctic Monitoring Assessment Program. So the CBMP is guided by a series of multi-year strategic plans. They typically run in 4 years. The current one expires in 2021, and now we're updating it for 2021 to 2025. Simply, the plans provide overarching goals and provide actions to deliver on these, and also align with a broader Arctic biodiversity assessment that the Arctic Council undertakes, with intention that it fits together with other Arctic initiatives, including SAM. Overarching goals include making the information relevant across multiple users, that it supports decision-making, and facilitates coordinating across all monitoring of this. It's also intended to be adaptive and sustainable in terms of capacity and financial. The Arctic biodiversity plans are across each of the 4 ecosystems to improve the ability to detect and understand change. This includes standardizing, coordinated monitoring, and synthesizing essential data. So in terms of these 4 steering groups across the marine, freshwater, terrestrial, and coastal plan, the freshwater and marine ecosystem reports have already been completed, and the terrestrial is focused on a report that is in press right now. It's going to be referred to the START, and I can amend a link in the chat section. In terms of the coastal plan, they are the last formed group, and they are working on an implementation plan for the coastal regions across the Pan-Arctic. And that is the first one of these monitoring groups that have incorporated traditional or indigenous knowledge from the beginning. So as they were measuring focal ecosystem components, they came up with different ways to depict that. So when they had the indigenous holders participating in and identifying these focal ecosystem components, they talked about timing of harvest, they talked about taste, and they talked about key elements that are important to their subsistence and traditional lifestyles. So the next strategic plan that I mentioned is going to be developed from 2021 to 2025 is going to continue on these developments, and will work better towards integration across all these 4 monitoring groups together to provide perhaps some more relevant case studies that we can then convey through outreach documents. Linkages to the Arctic Observing Summit and other international efforts. CBMP is cross-cutting across multiple Arctic Council working groups and leverages assets provided by many international networks. CBMP data are paramount to the design coordination of Arctic observing systems across the Arctic to ensure that societal and scientific benefits occur. In terms of data sharing and engagement, the CBMP has been recognized by the UN Convention of Biological Diversity as the official Arctic Biodiversity Network of GeoBON. And here on this slide, I talk about the Arctic Biodiversity Data Service. And that's the mechanism where CBMP reports and activities are made accessible, and it's online. It's interoperable data management system for biodiversity data that's generated from the conservation of Arctic flora and fauna overall. And the goal of this data service is to facilitate access, allows for integration, analysis, and display of biodiversity information for scientists, practitioners, managers, policymakers, and other working groups to understand and conserve the management of Arctic's wildlife and ecosystems. The CAF works within a range of partners to further develop cooperation and access to manage biodiversity data, and the ABDS serves as the Arctic node within the Global Biodiversity Information Facility, also known as GBIF, and the Ocean Biogeographic Information System, also known as OBIS. And so there's many examples of who uses the data that's provided in the Arctic Biodiversity Data Service. Many of the UN reports utilize it. There's a EU work package called Interact that's a good example that allows monitoring programs to tie their work into CBMP. So I encourage you to either take a look at the ABDS website. It's essentially a portal. It's www.abds.ai. And if you want any more information on any of the efforts of CBMP, please don't hesitate to reach out to myself or other co-lead Tom Christensen from the Kingdom of Denmark. Or if you want other information on work efforts for the conservation of Arctic flora and fauna, I suggest that you reach out to Tom Berry, the lead author on this working paper, as well as the CAF Executive Secretary.
Thank you so much, Kathy. Do we have any questions or follow-ups for Kathy? Okay, so next we will move on to Michael. Michael's short statement was titled Improving and Expanding the Environmental Monitoring Efforts of Expedition Cruise Ships in the Arctic. Over to you, Michael.
Yeah, Michael Køj Poulsen here. I will try to share a screen here. Don't know what is happening there. Share. Do you see anything?
We do, yes.
Yes, that's good. Okay, so I will present a short statement on improving and expanding the environmental monitoring efforts of expedition cruise ships in the Arctic. The EU-funded INTAROS project tried to develop an efficient integrated Arctic observing system by extending, improving, and unifying existing and evolving systems in the different regions of the Arctic. The INTAROS project has a work package on community-based observing where I take part. As you know, large parts of the Arctic are rarely visited by anyone, including scientists. This is partly because of the high costs. Involving local stakeholders in observing may make sense both to lower costs and to include them in the dialogue on needed conservation management interventions. We have chosen Disco Bay in Greenland and Longyearbyen in Svalbard for our case studies. First, we ask who is already there and what is already done. We hope to learn from the existing and build on that. Disco Bay has local fishers and hunters who can observe almost everywhere all around the year. Svalbard is different. Who is getting around like the hunters and fishers in Greenland? Tourists on board cruise ships are. Expedition cruise operators, guides, and passengers regularly visit remote areas. They might find it meaningful to contribute. Expedition cruises typically have highly educated and motivated guides and guests. Expedition cruises may have the potential to support environmental protection efforts by obtaining information that can help scientists conduct research and provide a better basis for management decisions. Many expedition cruise operators are already participating in environmental monitoring in different ways. We have already seen that tour guides and passengers can contribute meaningfully. With this in mind, we contacted AECO. AECO is the Association of Arctic Expedition Cruise Operators. They work for responsible Arctic cruise tourism. They want to ensure that expedition cruises and tourism in the Arctic is carried out with consideration to the vulnerable natural environment, local cultures, and cultural remains. As I understand it, they were formed in response to authorities in Longyearbyen getting worried about the pressure from tourism, that it was too high. AECO is like an NGO with people who wants to do it better. They have issued many guidelines for members to follow. AECO helped finding cruise operators interested in working together with us, and we have discussed with them over Skype and agreed on a workshop. In March 2019, we had a workshop in Svalbard where representatives of cruise operators, citizen science programs, local government, and scientists came together to exchange experiences on environmental monitoring from expedition cruise ships and to discuss a pilot project for 2019. We wanted to test and learn. We are working to understand the potential, also with focus on how observations can lead to action. It looks like the environmental observing efforts of expedition cruise ships may improve the long-term monitoring and management of climate change challenges, wildlife, and cultural sites. Cruise ships may help just by carrying scientists or equipment like ferry boxes with little help from guides and guests, but they can also facilitate citizen science approaches like observations from guides and guests, photographs, or collection of water, ice, soil, and debris samples for later analysis by scientists, etc. So the observations are needed. How can we structure, streamline, and improve? What is the potential? So I'll show you a slide here where just the first idea about how it is now. Many of the cruise ships, they observe and record and send observations to different citizen science programs. So on the next slide, it's a way to, maybe it could be improved. And I see the middle like a bridging organization that Joseph was talking about. This is just like a first idea about how things could be improved. It may be possible to learn from existing efforts built on this and extend the citizen science monitoring to even more cruises. Inputs from cruise expeditions may become more useful if methods communication is standardized to a larger degree. We need better understanding on how to make observations relevant to decision makers, how to communicate to decision makers, how to give feedback to guests and guides, and so they can see the importance of the observations. For the 2019 pilot, we have focused on seven different citizen science programs. So see, yeah, eBird is like the most used. In 2019, there have been 76 persons that have uploaded 2,719 checklists from Svalbard. And another popular one is Happy Whale. Here I just show the records of blue whale. If I had chosen humpback whale, there would even have been more. They have had records from 22 different cruise ships, cruises, where they have provided photographs of 75 encounters of 13 species. Other things we have tested is like the Secchi disk study and cloud observations from NASA globe, and tidal glaciers and hotspots for top predators, and plastic debris on Arctic shores. And also we have hoped to test cultural historical site photography, but we have not really been able to find any citizen science program that really are able to take this kind of information. Tourists goes everywhere, and many have stories about cultural sites that get damaged, and we think it could be worth to have a more structured monitoring from the visitors. They could take photographs and they could be following the different sites over the years. Yeah, I will finish with showing you the workshop report from our workshop, and there's a link there. Thank you very much.
Excellent. Thank you so much, Michael.
Yes.
Do we have any questions for Michael? So Michael, one question that
I will try to get out there of sharing.
Sure. So we had one question from several people asking about the resulting data. I guess from the citizen science programs and cruise operators, you mentioned in your paper that they will own the monitoring, they will own that data. What guarantees do members of the community have that that data would be shared as widely as possible?
Yes, this is, if I understand it right, you talk about the local communities and their ownership of the data. This is not really like a community. That is like you talked about the Arctic observers. This is guests, visitors, and of course the cruise operators can be companies that are placed in the Arctic. Of course, I don't know, they are in charge of the whole thing themselves, what they want to communicate.
Okay, great. Any questions for Michael? All right, thank you again, Michael. We are down to our last presentation. We appreciate your patience, everyone. And we'll have Finn Danielson. He'll be presenting on his short statement towards the increased use of local knowledge in international management bodies, advisory services. Over to you, Finn.
Thank you very much, Ravi. Can you see my first slide?
Yes, we can. If you don't mind making it larger. So there we go.
Great, thanks. Thank you very much for the opportunity to join this session today. It's a tough time. I've got 3 kids here that they're asking for food. I'm supposed to start making it half an hour ago, but I'm trying to keep them away from the door here. But I'm sure you're all facing the same situation. So I'm going to speak to you about a new initiative that demonstrates maybe kind of a bottom-up perspective of what are the kind of some of the challenges there are to observing systems and to getting the observation translated into action on the ground. I'm going to talk about the efforts to increase the use of local knowledge in international management bodies, advisory services. And this is a collaborative initiative with the Nunavut Wildlife Management Board, with the Association of Fishermen and Hunters in Greenland, and the Center for Nordlige Folk in Norway, and Stockholm Resilience Center. As I think you're all aware, there are a number of international agreements like the CBD, IPBES, Intergovernmental Policy Platform on Biodiversity and Ecosystem Services, and other agreements are putting emphasis on the need for incorporating experiential knowledge, local and indigenous and local knowledge into not only science, but also into decision-making and management of natural resources. However, there's a huge gap between the policy and the practice in the Arctic. We also see right now the largest change in the distribution of life on Earth caused by climate changes for 25,000 years. Species are moving higher up the mountains, deeper into the seas, and towards the poles. And there's a huge need to shorten the gap between observation and action. And one of the ways to do that is to incorporate local knowledge into decision processes. And I'm going to speak to you about a new initiative by resource users to increase the use of local knowledge. We've seen that in some community-based monitoring programs, hundreds of management proposals with supporting data have been made by small-scale resource users. For instance, the Greenland government program, Pisuna Net, led by the Ministry of Fisheries and Hunting and Agriculture in Greenland. There, hundreds of management proposals have been proposed, yet only few have been acted upon by the authorities. And this is often because international management bodies, they have made recommendations that contradict the resource users' proposals. International management bodies are, for instance, organizations like NAMCO, North Atlantic Marine Mammal Commission, CITES, Convention on International Trade in Endangered Species, ICES, International Council for the Exploration of Seas, NAFO, North Atlantic Fisheries Organization, and a number of other international bodies. They generally say these international management bodies that they want to incorporate local knowledge into the processes of when they're providing scientific advice to the Arctic governments, but they are having big difficulties in turning this policy wish into practice. And so representatives of different small-scale Arctic resource users like the Nunavut Knowledge Management Board and KNAPK, the Greenland Association of Fishermen and Hunters, and others have got together and started a cooperation with scientists to try and give small-scale resource users a voice in these international management bodies that advise the Arctic authorities on resource management. And we've had a number of Skype dialogues, and we're planning a workshop in Nuuk in Greenland later this year. And the guiding questions that we are trying in this network to solve, to answer, is which natural resource management interventions are taken today in the Arctic with guidance from the international management bodies, what kind of knowledge is being used, and where do the management bodies get this knowledge from? And where are there opportunities so that resource users' knowledge can be further incorporated? And what's being done today in relation to utilizing local knowledge for informing the advice provided by the management bodies? Because if we don't see a change soon in that the proposals are being acted upon to a larger extent, then there's a real risk that the community members spending their time and effort in community-based monitoring efforts will start, saying, okay, since we're not being listened to, why should we bother? I mean, we see that the governments say they want to listen to community members. We see that the international management bodies want to listen to community members. But in practice, we see that our proposals with supporting evidence are not being used, are often not being used. And it will also mean that the community members will not be interested in contributing their time and effort into the community-based observing work. So this is an example of a real need from the ground for being listened to and for seeing community members' own observations being used in practice to solve challenges that are crucially important for them. And in this effort, we've started with NAMCO and CITES, because in Greenland and Nunavut communities, these two international environment management bodies, they are particularly important for the livelihoods of hunters and fishermen and for the future of small rural communities. And so this is where we've started this work, and the work is ongoing, and it will continue with a workshop in Nuuk later this year. Thank you.
Thank you very much, Finn. Do we have any questions for Finn? Any comments? Okay, so thank you everyone for sitting through the last, I guess, hour and a half of these presentations. These presentations, again, mirrored white papers and short statements that contributed to Working Group 2's synthesis paper. We just sent a link out in the chat, just in case you missed that link, and that link really speaks to summarizing as well as expanding on the themes that Working Group 2 in our breakout discussions we'll look at in the next 45 minutes or so. At this point, I'd like to share with you a copy of the discussion template. And Maribeth, if you'd like to chime in terms of how many breakout groups you think we'll have.
Yep, so I think we can do 2 breakout rooms. Odile will create them, and people will be distributed more or less evenly into each group. We have an hour, almost an hour, 55 minutes left. I'm thinking that we could break out for about half an hour and then come back and report back. So there's a discussion template up on the screen now. That's the plan for each of the breakout rooms. I will moderate one and Ravi will moderate the other. I'm thinking we can take a 10-minute health break right now. People might like to do that if you haven't done it, and log in. Odile, will it just automatically sort people into rooms?
Yes, I will create the room and people will be sorted.
Okay, so if people want to take a 5-minute or so break, and then when you come back, you'll be in a room and we'll get the discussions going from there. I would just ask you to read through this template before we start the breakout sessions in. Well, my clock says 10:35 where I am, so let's come back at 15 till.
If people are going to break, don't disconnect or sign out of Zoom.
Right, right.
That's really important for the breakout room.
Right. Thanks for that reminder. And we'll have about a half an hour in the breakout room and then a 15-minute report back and then a longer break. And then this group will resume later on today. Sound good? Any questions? Okay, we'll see everybody in approximately 9 minutes. I'm just reminded that other group, they need to come back.
Sounds good. Yeah, I saw Odile. I saw a message at the top too, so.
Just wait another minute or so till everyone gets back. I know some people have had to leave.
Hey, Maribeth, so I think the majority of our breakout room participants are back.
Okay, so just a quick summary and then plan for this afternoon. Or we could just do a summary when we come back this afternoon.
I think that's a good idea. I think it'll give the rapporteurs some time to collate their notes.
Okay, do people feel comfortable with that? We'll get all the notes together from the breakout discussion. And then when we come back in a couple of hours, we'll have a quick overview of what happened in the breakouts. And then we'll move into the next part of our discussion. Yay or nay?
Sounds good.
Fine.
Thanks for leading us this morning or this afternoon.
That's fine for me too. Thank you.
Okay, that's great. Well, thanks everyone for participating. It's really good. I know it's a challenge, but we're doing a great job. And now I'm off to moderate a panel in half an hour, so maybe we'll see some of you there. And thanks to our technical support, Odile, good job.
Yes, thank you, Odile.
All right, we'll talk to everybody in a little while. Thank you.